These cracks are probably fissures where Europa's surface ice has split open and the liquid underneath has risen and then frozen again. Just like the ice that cracks on a lake, but on a larger scale. These were just guesses because Voyager did not have sufficient instruments to take pictures from beneath the surface. But these very speculations caused scientists' view of Europa to change completely until the next spacecraft arrived. If you've liked the story so far, don't forget to like it. Now let's go to the 90s, when NASA made a big decision. A simple flyby of Jupiter was no longer enough. A spacecraft had to be built that would orbit Jupiter for a long time, examine its moons from a close distance, and be able to send a huge volume of data back to Earth. This is how the Galileo project took shape. Proudly named after the same tenacious scientist who discovered Europa centuries ago. Galileo was launched into space in 1989 aboard the space shuttle Atlantis. But just a few months later, a major problem occurred. Its main high-gain antenna failed to deploy. This was a technological catastrophe because without that antenna, Galileo couldn't transmit information as it was designed to. The NASA team tried for months to perhaps open that antenna. They even resorted to strange maneuvers, but none of them worked. In the end, they were forced to use the emergency low-gain antenna. It was like having to work at dial-up speed instead of sending data through fiber optics. But this is where human ingenuity showed itself. Engineers redesigned the data compression methods. They wrote algorithms to be able to transfer the maximum amount of data at this low speed. And in 1995, the Galileo spacecraft entered Jupiter's orbit, delayed, with problems, but still ready for discovery. Over the following years, Galileo passed by Europa many times. Each pass was carefully planned to get the best angle for photography, magnetic measurements, and data collection. But the results were beyond imagination. The new images showed cracks that were much more regular and structured than what Voyager had seen. Some of these fissures were hundreds of kilometers long, but only a few kilometers wide. It was as if the ice plates on Europa's surface were moving, separating, and sticking back together, just like plate tectonics, but with ice instead of rock. In some images, pieces of ice were seen that had been lifted from their place, rotated, and then frozen again. Such a phenomenon is called rotational fracturing, and was another strong sign that something is moving under this ice, like an ocean. But perhaps Galileo's most exciting discovery was related to measuring Europa's magnetic field. Galileo had sensors that could record changes in the magnetic field around Jupiter and its moons. When it passed by Europa, a specific change in the magnetic field was recorded that could not be explained unless there was a conductive layer inside Europa. What could it be? Salt water. Salty water, just like seawater, can move electrons and change the magnetic field. This is one of the strongest pieces of evidence for the existence of a subsurface ocean on Europa. In addition, Galileo was able to estimate the approximate thickness of the icy crust, something between 10 to 30 kilometers of ice, and below that, perhaps up to 100 kilometers deep of liquid water. The more data that came in, the more complete the picture of Europa became. From a simple white moon, it transformed into a potential world, a place where, despite the cold and ice, a warm heart of subsurface water is beating. If you think Europa's oceans are like our own, I have to say, not exactly. First, on Europa there are no waves, wind, or rain. The hard frozen surface completely covers the ocean beneath it like a very large lid. No light reaches it, no waves crash below, and there is no sound. Just a dark, cold, and deep world. But despite this apparent silence, down there everything might be churning, because internal heat and Jupiter's tidal forces keep the water in motion. Just like a water well boiling in the dark, only on the scale of a moon in space. The stranger point is that although Europa itself is smaller than our moon, its subsurface oceans probably contain more water than all of Earth's oceans combined. Imagine a small icy ball, but with a heart full of water. If you thought Earth was the most special water world, you need to look at this moon again. But I mentioned internal heat. How is that possible? How can there be liquid water on an icy moon so far from the sun? This is where the magic of gravity comes in, and of course, a little bit of physics. The moon Europa orbits Jupiter like a small ball, but the story is not simple. Because Jupiter is a very large gas giant with extraordinary gravitational power, when Europa gets closer to Jupiter, Jupiter's gravitational pull slightly stretches Europa's body. When it gets farther away, this pull becomes weaker. This constant pushing and pulling causes Europa's interior to be repeatedly compressed and stretched, just as if you were to continuously squeeze and release a plastic ball. And now, the important point. This constant pressure and stretching creates internal friction, which means heat. This phenomenon is called tidal heating. The heat is so intense that it can melt the ice from within and create a liquid ocean beneath its surface. And this isn't unique to Europa. The other Galilean moons, like Io, Ganymede, and Callisto, experience this same pull. So now, we understand why such an ocean can exist within Europa. But what happened to the Galileo mission? After nearly 8 years of continuous orbiting around Jupiter, the Galileo spacecraft reached the end of its journey. A mission that began with a faulty antenna ended with a wealth of scientific data and mind-blowing discoveries. But NASA had to make a tough decision. Should they let Galileo remain in orbit, or should they create an ending for it? Because Europa was a potential candidate for hosting life, scientists did not want to risk an old, contaminated spacecraft colliding with it and possibly transferring terrestrial bacteria to that world. Therefore, in 2003, they decided to send Galileo on a controlled entry into Jupiter's atmosphere. It entered the thick atmospheric layers at high speed and was destroyed forever in the heart of that gas giant. But this end was the beginning of a new chapter in the exploration of Europa. Our next tool for exploring this mysterious moon was not a spacecraft at all, but a space telescope in Earth's orbit whose name is familiar to everyone: Hubble. Although Hubble was at a great distance from Jupiter, its extraordinary optical power allowed it to see things that spacecraft up close could not. One of Hubble's most fascinating observations was of Jupiter itself, the Great Red Spot. That massive storm, which has been observed for centuries, was gradually shrinking. Hubble showed that this storm is no longer the giant it once was and is getting smaller year by year. Why? We still don't have a definitive answer. But these changes show that even within a planet of that magnitude, nothing is constant. But the discovery that captured the attention of all astronomers was something that happened on the surface of Europa. In 2012, Hubble's data revealed something strange. Images were captured that appeared to show plumes of water vapor erupting into space from Europa's surface. Initially, there was doubt. Were these optical illusions, or were they real? But when the same eruptions were seen again in subsequent years at specific moments, there was no longer any doubt. Europa, this silent ball of ice, was spewing water vapor from within, just like Saturn's moon Enceladus. These eruptions indicate that pressure is being exerted from beneath the core, meaning there is an active source of energy. And we discovered all of this with Hubble and other spacecraft. Of course, this is just the beginning, because our next instrument is set to continue this story with details beyond imagination. We know its name well: James Webb. One of the greatest recent scientific leaps was the launch of the James Webb Space Telescope.
After its launch in 2021, this ultra-advanced telescope, with its high infrared capabilities, entered orbit and has been able to provide a view beyond any instrument we have ever had. Now, Jupiter and its rings have also come under James Webb's lens. With its infrared vision, James Webb was able to reveal the details of Jupiter's thin and faint rings, which were previously not visible from Earth or by some spacecraft. These rings are very dim and at the same time hidden. But James Webb's infrared was able to detect the faint heat of the ice particles and dust within the rings. This means we were able to understand the rings, their distribution, and even details like the size of the particles. James Webb also helped us examine the interaction between the rings and Jupiter's magnetic field, and how this delicate structure is affected by solar winds and intense radiation. All of this gave us a deeper picture of the dynamics of the environment around Jupiter. When the James Webb Space Telescope targeted Europa, everyone was waiting for it to see something specific. Those same plumes of water vapor that had been previously seen with the Hubble Space Telescope. The ones that shoot out from Europa's frozen surface into space, and are signs of the ocean beneath the ice. But James Webb, despite having a much stronger vision, saw nothing. No vapor, no eruption, not a particle of water in the air. Nothing. Did this mean the eruptions were a mistake? No. The issue is that those plumes are likely very short-lived and transient. This means they might only occur very quickly for a few hours at certain times, and when James Webb was observing, those eruptions were not happening. But now let's get to something much more exciting. James Webb examined a specific region of Europa's surface and found a clear sign there. Carbon dioxide. The same gas we produce on Earth by breathing. Where did this gas come from? From outside Europa? A meteorite? No. Detailed analysis showed that its origin is likely from within Europa, from that same ocean under the ice. This means this gas came up from below the surface, from the depths, and settled on the ice. And this indicates something very important. Inside Europa, there's not only water, but also carbon. This is very important. Carbon is considered one of the essential ingredients for the origin of life. All living organisms that we know of are made of carbon-based compounds. Now, imagine for a moment an icy world far from the sun, which has water, heat, and carbon beneath its surface.
This means three important elements for the formation of life are present there together. Don't forget that without even drilling or landing a device on the surface, we were able to understand from the outside what is going on in the heart of Europa. But NASA is not content with this and is planning to go there again. It's time for a direct and very serious mission to enter the story: the Europa Clipper mission. Humanity's greatest hope for unlocking the secrets of one of the most fascinating places in the solar system. This time the goal is not just to look. Europa Clipper is designed to repeatedly fly by Europa's surface at very low altitudes, with some passes even below 30 kilometers. The most important instruments it has are very high-resolution cameras to take unprecedented quality pictures of the surface, spectrometers to identify the chemical compounds on the ice, an ice-penetrating radar that can probe the depth of the ice and examine the moon's internal structure, and a particle detector that can directly analyze any vapors coming out from the surface. And most importantly, this spacecraft can analyze the eruptions that likely come from the subsurface ocean as it flies through them. This means it can pass through these plumes without direct drilling and study them. The story of Europa doesn't end here, because the James Webb Telescope is still sending new data from every corner of the solar system every day. If you enjoyed this style of video, be sure to subscribe to our channel to watch future videos. Thank you.